Hello everyone. In this tutorial we will solve a question based on the overlap add method. Now here we are given an input sequence and also the impulse response of the filter, and we are told to find the output sequence by using the overlap add method. Now first we will find the value of m. Here m is equal to the length of the impulse response of the filter. So as there is 3 elements in the impulse response, so the length of this impulse response is 3. Then we will assume the value of L as 2. Why I have done this, I will tell you this later. And we will find the value of the input data block by using this formula L plus M minus 1. So this becomes 2 plus 3, that is 5 minus 1 is 4. So the value of the length of the input data block is 4. Now what is this input data block? Now we see that the input sequence that is given to us in the question is very long, and the calculation to find out the output sequence becomes very difficult. So to reduce this difficulty, what we do is we divide this input sequence into segments of shorter lengths which are known as blocks. So what we'll do is we will divide this input sequence into input data blocks, and we will calculate the value of output data block individually for each input data blocks. Now what should be the length of this input data block? So n is equal to L plus M minus 1 is equal to 4. So in this question I am taking the value of L as 2, and so I found the value of the length of input data block as 4. Now you can take the value of L as 3, L as 4 or L as 1. Now what happens when you take the value of L as 3? When you take the value of L as 3, the value of n, that is the length of the input data block, will increase. Also the number of input data block that you are taking will decrease. If you take L is equal to 4, again the value of the length of the input sequence will increase, and the number of input data block that you are taking, it will decrease. Look, you will get the same answer when you are taking L is equal to 3, 4, 1 or 2. But the thing is, when you are taking L is equal to 3, 4, again the calculation will become a bit difficult because the sequence will increase. So what I prefer is, I always prefer taking L is equal to 2. Even you can take L is equal to 1, you will get the same answer, but I prefer taking L is equal to 2, and then with the help of this I find the value of n, which is given by L plus M minus 1, which is equal to 4. The input data block is formed by taking L samples from the input sequence and adding M minus 1 zeros at the end of each input data sequence. So the input data block, it is formed by first taking the L samples from the input sequence. So the value of L is 2, so we will take L samples, that is 2 samples from the input sequence, and then we will place M minus 1 zeros at the end of this input data block. So M minus 1 zeros, we are going to put it over here. So that's why we have so now we will find the value of M minus 1. So M minus 1 becomes 2. So we will add 2 zeros at the end of each input data block. So let us start. So the first input data block. So first we have to place 2 samples because the value of L is 2. So we will place the 2 samples first. So 1 and 2 we will place from the input sequence, and then we will place 2 zeros as the value of M minus 1 is 2. So we will place 2 zeros at the end. Then for second input data block, we will place the next 2 input sequence, the next 2 samples from the input sequence, that is minus 1 and 2, and then we will place 2 zeros at the end because we have to place M minus 1 zeros at the end, and the value of M minus 1 over here is 2. Then for third input sequence, we will put next 2 input samples from the input that is given to us in the question, that is 3 and minus 2, and we will place M minus 1 zeros at the end. So M minus 1 over here is 2, so 2 zeros. Then the fourth input data block, so we will take L samples from the input sequence that is given to us. So the value of L is 2, so we will take now 2 samples, that is minus 3 and minus 1. So minus 3 and minus 1, and then we have to place 2 zeros at the end of the input data block. So M minus 1 is 2, so we will place 2 zeros, 0 and 0. Then for fifth, again we have to take 2 samples from the input sequence that is given to us. So 1 and 1, and then again we will place M minus 1 zeros at the end. So M minus 1 is 2, so 2 zeros. Then the sixth input data block. Again, we have to take two samples from the input, so 2, -1, and we have to place m-1 zeros, so this becomes 0, 0. So here we have to stop, and now we will be calculating the output for each input data block. Now we have successfully found the value of the input data blocks. Now we will be finding the value of output data blocks for each input data blocks. So we will use the circular convolution to find the output data block for each input data block. Now the length of impulse response is 3 and the length of each input data block is 4. So we have to make the length of impulse response equal to the length of each input data block, that is 4. So now what we'll do is we'll pad 1 0 to impulse response of the filter. So let us start to find the first output block. 1 2 3 0, we have to pad 1 0, then we have to apply the circular shifting, so 0 1 2 3, then this becomes 3 0 1 2, and this becomes 2 3 0 1, and then we have to take the first input data block, that is 1 2 0 0. Now let us solve this. So this will be, if we multiply this column with this row with this column, so we get this as 1 plus 0 plus 0 plus 0. If you multiply this row with this column, so we'll get the value as 2 plus 2 plus 0 plus 0. Again, if you multiply this row with this column, we get the value as 3 plus 4 plus 0 plus 0. And if you multiply this last row with this column, so we get the value as 0 plus 6 plus 0 plus 0. And we get the final value as 1476. Same for second output data block. Again, we have to apply the circular shifting for impulse response. So 1 2 3 0, 0 1 2 3, 3 0 1 2, 2 3 0 1, and we have to consider the second input data block, that is -1 2 0 0. And if we again, if we calculate this, we find the value as -1 0 1 6. Then for third input data block, again circular shifting, 0 1 2 3, 3 0 1 2, and 2 3 0 1. Then we have to consider the third input data block, so this is 3 2 0 0, so 3 2 0 0, and we get the value of this as 3 4 5 -6. Then the output of the fourth input data block, so again we have to apply the circular shifting, 1 2 3 0, 0 1 2 3, 3 0 1 2, 2 3 0 1. Then we have to consider the fourth input data block, so it is -3 -1 0 0, -3 -1 0 0. If we solve this, we get the value as -3 7 -11 -3, so -3 7 -11 -3. Then the output for fifth input data block will be, again apply circular shifting, 0 1 2 3, 3 0 1 2, 2 3 0 1, and we have to consider the fifth input data block now. So the fifth input data block is 1 1 0 0, so 1 1 0 0. If we solve this, we get the value as 1 3 5 3, so 1 3 5 3. And for sixth input data block, its output will be, again apply circular shifting, so 1 2 3, 3 0 1 2, 2 3 0 1. And if you take the input data block of this, it is 2 1 0 0, so 2 1 0 0. And if you solve this, we get the value as 2 3 4 -3. Now over here we have successfully found the output data block for each input data block. Now we have to find the final output, that is y of n. Now here the last m-1 samples of each output block must be overlapped and added to the first m-1 samples of the succeeding block. Now the value of m over here in this question is 3, as the length of impulse response was 3, and the value of m-1 is 2. So the last two samples of each output block, it must be overlapped and added to the first m-1 samples of the succeeding block. This is the succeeding block, the second output block. This is the succeeding block for this first output data block. Similarly, the last m-1 samples should overlap and be added with the first m-1 samples of the succeeding block. So here m-1 is 2, so we will be overlapping and adding it with the two samples of the succeeding block. So it is 3 and 4, 5 minus 6. Similarly, we have to proceed further. Minus 3, minus 7, minus 11 and minus 3. Again we have to proceed further similarly. 1, 3, 5 and 3. And this is 2, 3, 4, minus 3. Now first, to find the output sequence, what we'll do is we'll place this two samples as it is not overlapped and add it with any of the samples. So we will first place this over here, 1, 4. Then we have to add the two samples. So 7 plus of minus 1, 7 minus 1 is 6. Then 6 plus 0 is 6. 1 plus 3 is 4. 6 plus 4 is 10. 5 minus 3 is 2. Minus 6 minus 7 is minus 13. Minus 11 plus 1 is 10. Minus 3 plus 3 is 0. 5 plus 2 is 7. 3 plus 3 is 6. Again, this 4 and minus 3 is not overlapping with any of the samples, and it is also not added with any samples. So we'll consider 0, 0 and overlap and add it. So this becomes 4 and minus 3. So this is how we find the output sequence by using the overlap add method. Now you try by taking L is equal to 1, 3 and 4 and see whether you're getting the same answer or not. Thank you for watching the video. Please like and subscribe.